Chapter 6, Video 6, Trig Identities, bum bum bum. This is Miss Oshier.
And Miss LaHart.
And, I like that one.
Yeah,
Here
thank you.
we go.
All right, everybody, this is going to be a hard topic.
Not really. You're just going to whine because there's lots of letters and words and
And
you
you
get
have to think.
scared. Yeah,
You have
it's
to
not really
think.
that bad. It's like a fun puzzle.
All right, so anyway, an identity is an equality between two functions that are differently defined. So basically what you have to do is to prove an identity is you have to manipulate an equation to get one side equivalent to the other side.
So what does all that mean?
Just get one side equal to the other side.
Got it.
Rewriting it.
Bam. See, lots of words. It's very simple, though.
Okay? You do have an arsenal or a toolbox, if you will, of tricks. Your reference sheet will contain all of these things.
Bam.
So, I think
You
there's
should
a
know
couple.
that what tangent and cotangent are. You should know what all of those are, but you will have them.
Pythagorean,
These are the good ones.
Yeah, Pythagorean identities. Okay, we're not going to go over too much of how they come about, but remember, it's a unit circle. X squared plus y squared equals 1. That's a good one.
This is a big one.
Yep.
Yep.
Basically, you're going to use any form of these equations, and then even versus odd identities. We'll talk more about this when we get into graphing these things, but you still need to work it. So just go with it.
You're definitely, these are the ones that you need your reference sheet for. These you should know, but these you definitely, we need the reference sheet for them.
Right. So helpful hints for this. So just work on one side of the equation. Pick the one that looks the ugliest and work with that.
Break it down.
More complicated side.
Yep. We
just
said the same
said
thing. So if nothing else is available, you can change all terms into expressions containing sine and or cosine, then simplify. So when in doubt, try to get as many sine and cosines as you can.
All right. Here we go, peeps.
So this is what we mean. I see a cosine, I see a sine, then I see a tan. I don't want that tan. I want lots of cosines and sines. So I'm going to switch tangent to sine over cosine, which is not that difficult to do. Now, as you can see, I'm multiplying fractions, so I can reduce the cosines. They can cancel out. Boom.
Leaving me with
Sine equals sine. Done.
done. That's all you have to do.
This is your goal. Goal reached. Check mark.
to get one side equal to the other side.
Boom. Let's keep it rocking.
Okay?
Whoa.
So, Pythagorean identities, you don't always use them as they're written. You've got to be able to, you can move them around because it's equality.
Right.
So,
You got to be able to manipulate them.
True statement. So do you see how in the problem we have cosine squared of theta? I see up here I have cosine, well, theta, alpha, whatever works. But if I get the cosine by itself,
So if we subtract sine squared theta, it looks like this. And now we have cosine squared theta equals this. So this guy can get substituted in.
oh, I'm underlining it.
Boom.
All right, now 1 minus sine squared. Doesn't that remind you of something?
Squared,
One
subtraction.
squared difference.
Oh, difference of perfect squares.
Yes, I know it's ugly and it's weird, but that is a difference of perfect squares.
It is, because this is just like 1 minus x squared. Remember when we did our whole x's instead of sines thing? Yeah.
Yep. So if you write it like that, then you see that 1 minus sine of alpha, 1 minus sine of alpha can reduce each other.
Oh, we can cross them out. Yes.
And then you have 1 plus, and because of the commutative property of addition, one side equals the other side.
Oops, sorry, I thought we were going to do that
Check.
one part. Check.
Boom.
Yep, these are the same.
Yep.
It's pretty if you show us the other step, but this is fine.
Yep. We're good with that.
I keep forgetting that you can't see me because I'm doing all sorts of fun hand movements.
She's almost hit me
but
like
you can't
4
see
times.
me. And I'm like,
If,
oh, yeah.
if you hear ow, it's okay. She just hit me.
Oopsies.
All right, we got negatives. So
Okay. I'm scared, but I have this reference sheet. Okay, so sine of negative theta is negative sine theta. Oh, okay, so I can quickly switch those puppies. Okay.
cosine of
Cosine negative x, I should have paid attention, is positive cosine, so that's why that looks like that. And what's sine divided by cosine? Oh, it's tangent. But it's a negative divided by a positive, so it's negative tangent.
Well, we could write it, you can pull it out, make
Winning.
it like official, and then you've got, oh, that's equivalent to that. Boom, boom.
Check. Boom.
Done. Oh, snap. All right, let's see
They're
here.
getting harder.
They are getting harder.
But
All
we
right.
can do it.
We can. Let's see what, that makes me worried. I don't really remember what progress we here. Let's click next. I think we use,
Boom. Okay.
oh, yeah.
So secant squared theta, I'm seeing this puppy over here, is the same thing as tangent squared theta plus 1. So if we subtract 1 from both sides, that means tangent squared theta is equal to this guy.
Yep.
So that's where this came from.
Okay.
It's all about manipulating things.
Okay.
And now remember when we talked about sines and cosines and that kind of stuff? We want to have as many sines and cosines as we can. So tangent is sine over cosine. So tangent squared is sine squared over cosine squared. Cross them out.
Cross
Done.
out the cosine squared. Boom, boom, done.
Now, we don't want you to think there's only one way to do these. You very well at this point could have said, all right, maybe I should do this cosine squared thing over here. You know, you're going to have to try it.
Yep.
There's, you know, someone might take 20 steps, someone might take 3 steps. It's all just what you saw and the way you went.
Right. And yes, these are tricky, but you got to just start somewhere and go with it.
You can do it. Practice makes perfect.
All right. So I see the sine squared minus 1 again. And then if I look at the bottom, I see that both terms have a tangent. So you know what? I'm going to do the difference of perfect squares on top and then take out a tan in the bottom.
Oh, I like it.
Ooh.
So again, difference of perfect squares, and we GCF'd the tan.
Okay.
And now we can cross those out.
Yeah. Okay. So that gets me to that point. All right.
And
now,
notice, we didn't even touch this side yet. We didn't even want to touch it. We just focused on the left side. Okay.
All right. Now, because of rules of fraction, so remember back to your fraction rules, I've got 2 pieces in the top over the same denominator. I'm going to pull those 2 things apart.
This is like 1 plus 3 over 4. That's the same thing as 1/3 plus 3/4, or whatever, whatever numbers I just said. You know what I mean?
Yep. So now, if I look at it, 1 over tan theta gives me my cotan of theta. That's, you know, that piece right there. But now let's talk about the sine theta divided by tangent of theta.
Sine over cosine. Whoa.
Whoa. So remember, fraction rules, you keep the first, you change division to multiplication, and you multiply by the reciprocal.
Boom. So in case you're unclear, we're dealing with this right now.
We're trying to work with this guy.
We've changed this guy to this, and it's now this.
Yep. So then once we do that, we see the sines cancel out, leaving me with cosine. So that sine theta over tangent theta is equivalent to cosine. 1 over tan is equivalent to cotangent.
So we're there.
We're there.
Boom.
One side equals the other side.
Boom. Look at us go.
Woo!
Okay, here we go some more. All right. On the right side, I can't really do anything because I'm at cosine and sine. Remember, it's kind of your goal to just have cosines and sines. Sometimes not, but for the most part, we're good. So we need to focus over here.
All
I
right.
see a secant squared and tangent squared. So I'm going to look all over here. Oh, this guy has those too.
Okay.
So if I were to manipulate those,
if I take secant squared and just plug in tangent squared plus 1,
bam,
okay. And then I notice in the top,
that I have difference of perfect squares.
well, I think the tan squared theta
Just
and
kidding.
the negative tan squared theta are going to cancel each other out.
Again, you can do it lots of different ways. But
True
okay,
statement.
tangent squared theta minus tangent squared theta cancel. So we're just left with 1 plus tan theta. Bam.
All right, now I'm going to try the technique before. I'm going to pull those 2 fractions apart. So 1 over secant, I know that that's cosine.
Uh-huh.
And then if I take tangent of theta over the secant of theta, as you can see, I rewrote it.
Whoa, whoa.
Tan is the same thing as sine over cosine. Secant's 1 over cosine. Keep the first fraction, change division to multiplication, and multiply. You get sine of theta. So,
We have cosine theta plus sine theta.
which equals cosine theta of sine theta.
Because again, this we said was cosine theta, and then this was all this.
All that work.
You're gonna need some space.
Yep.
You might need scrap paper.
I did provide lots of space for all of you. You're welcome. All right.
Negatives. So we go up to this guy. So cosine negative theta is positive cosine theta. Great. Sine of negative theta is negative sine theta. So we can switch all those.
Okay. Oh, this one I did a different route because, like I
we're
said,
working
there's
two
there's a couple ways you can do this. One of the other ways is that you come up with one of your Pythagorean identities, which is where this is going. So just follow us for a minute.
If you end to one of these, you're done as well.
Right. You don't have to get one side equal to the other side. You can also come up with a Pythagorean identity and then just end it right there.
Boom.
So what happened here, I tried to go this method. So I did change the left side and I did change the right side.
We're doing 2 sides at once now. Now we've graduated. So 1 over cosine was secant, tangent, sine over cosine. Okay. Common denominator.
So I combined
So we
it.
can combine. So now we got something kind of happening here, it's looking like.
When you cross multiply, okay, you're going to be left with cosine theta times cosine theta, which is the cosine squared theta. And then that right there, those are conjugates. So I know that when I FOIL them out or double distribute them out, you're going to be left with 1 minus sine squared theta. And if I rearrange the sine squared theta, boom, I've got myself a Pythagorean identity.
So pretty. And you might be like, it doesn't say that. Guys, addition's commutative. Come on.
True statement. So that's another route you could take.
Yes.
If you come up with a Pythagorean identity, you don't have to go any further.
All right, so now we see sine theta over 1 plus cosine theta. I can't do anything with those because they're just flat out sines and cosines. I have 1 plus cosine. Well, something is ringing a bell to me over here.
I'm going to make them have
there we
the
go.
same denominator. Okay, so I didn't show too much work, but let's just talk through this. So if I want common denominator, I have a denominator of 1 plus cosine of theta and sine theta. When in doubt, multiply them out. So my common denominator is sine theta times 1 plus cosine theta.
So on this side of the addition, we need to multiply both top and bottom by sine, leaving us sine squared theta over the common denominator that we're getting. And up here, we need to multiply top and bottom by 1 plus cosine theta, which 1 plus cosine theta times itself is written right there.
All right.
All over your common denominator, and we're still working that. We're not even touching the right side yet.
Nope.
Okay.
So I'm going to take from one step to the other step. What we did was we've, double distributed that out of there. So you were left with, I kind of partitioned it off, but you were left with cosine squared theta plus 2 cosine theta plus 1.
So this is what you got when you double distributed your 1 plus cosine thetas.
Yep. Sorry, I skipped 2 ahead. But whatever.
That's okay. And then this sine squared theta, but she grouped these here to make you realize, hey, it's this guy.
That guy. So that can be replaced with a good old 1. And then if I simplify the top, I got 1 plus 1, so I can combine that to be 2. Then I noticed in the top I can take out.
it?
I can take out a 2.
And because of commutative property, those are the exact same thing. That's crossing out.
So those cancel, and then 2 over sine theta, which is equivalent to 2 times cosine theta.
Whoops. And yes, it would be prettier if you, wrote that, but we're good. We're good at that point.
The last one.
Are you tired yet? You guys got this. Okay. Tangent theta plus cotangent theta over secant theta times cosecant theta equals 1. So I'm thinking I might be using one of these at some point, but you never know. What you think might not always happen, people.
What? So we changed everything.
So sine, cosine, cosine, sine. Secant is 1 over cosine. Cosecant is 1 over sine. Okay. Still can't do too much. So in order to add fractions, we need common denominators. So we multiply top and bottom by sine on this side, which is why you have the sine squared theta. Top and bottom by cosine on this side, which is why you have the cosine squared theta. And then if you just multiply these guys, that's what you got there. When you divide, you're actually multiplying by the reciprocal. And we substituted this Pythagorean identity for 1.
All right.
We have to see where the slides take us because
I forgot.
Well, and you can always do it in multiple ways. Like
Right.
right now, I might be seeing one way, but when we did it on the slideshow, it was a different way. So, oops.
True statement. So anyway.
Everything cancels.
Everything cancels to 1, which is what you wanted. 1 equals 1. Done.
Done.
Don't worry. We'll do some with you in class.
The goal is to be patient, not whine, and try.
Right.
If you have not tried before asking for help, and you are whining, you will not receive what you want. Have a fantastic day.
Woo.